All right. Hello. We've got our exponential review here, and I'm going to go through it pretty quickly. Please comment. Let me know if there's anything that you want me to go over in more detail. So, when I'm looking at an equation, I want to always start with the y-intercept. That's the one that has x equals 0. So, I start my equation telling you what the y value is. The y value is equal to 8. Because it's a curvy thing in our exponential unit, we know it's an exponential problem. We know it's an exponential equation. So I just know it's going to be some number inside those parentheses raised to the x power. So the only question left is 8 times what makes 11.2? In other words, 8 times some multiplier is 11.2. I don't expect anybody to know the multiplier off the top of your head. If it was 8 times something equals 16, maybe I'd expect you to do it in your head. But 8 times something equals 11.2? I don't know. You just divide by 8 and grab your calculator. Don't do it in your head. 11.2 divided by 8 is 1.4. That's my multiplier right there. That's my whole equation. I'm done with problem 1. Every single time that you do one of these graphs, you start with the y-intercept, you multiply by something raised to the x, and the thing that you multiply by, notice it was the second y value divided by the first y value. It's going to be 4 divided by 5. That is a perfectly good answer to put 4/5 in there, or if you like decimals, to put 0.8 in there. Both 4/5 and 0.8 would get you full credit. They're exactly the same. The most important thing is that it is always the later y value divided by the earlier y value. Some people get mixed up. They're like, well, I do one thing if it's growth, I do a different thing if it's decay. No, it's always the later y value divided by the earlier y value. That's why I took the y value that comes second and put it on top, and the y value that comes first and put it on bottom. It's the later y value divided by the earlier y value. That's your multiplier. All right, moving on down. Some people get hung up on these simplifying problems too. We're simplifying exponents. And they're like, well, I know how to do it if there's two things, but I don't know how to do it if there's three things. So just do it two things at a time. Let's do these two first. What do we do when we're multiplying things and they have the same base? We add the powers. So 6 plus negative 3 makes 3. Did I do anything to the x to the 0? Nope. Just write it down again. Now it's the same sort of problem. It's two things multiplied with the same base. 3 plus 0. That's it. Okay, let's do part B. What do I do when I multiply two things with the same base? I add the exponents. So should be B. I don't know why I wrote x. 12 plus negative 8 is 4. Did I do anything with the over b to the ninth? Nope, so I just write it down again. Okay, what do we do if we divide two things that have the same base? Well, dividing is the opposite of multiplying, and so subtracting is the opposite of adding. 4 minus 9 is negative 5. Top minus bottom. Done with those. Okay, question 3 is just a little bit of function notation. We have functions here, and we're asked to plug the number 4 into f, the number negative 3 into g, and the number 7 into h. Just be careful because there's no reason we have to write them in the same order. On the test, it might happen that we give you f, g, and h in order, but then we ask you about like g of 4 and f of negative 3, and we ask you to plug things in out of order. You're always just matching the letter with the correct formula. So f of 4 means put 4 into the f formula. That's all it means. So you can do it. All it is just matching up the correct formula with the correct input. So I'm going to type them all in, and I want you to look at the calculator in just a second to see how I type them all in. So you can see those last three lines right there. 23 1/2 to the 4, that's f of 4. 15 plus 5 times negative 3, that's g of negative 3. 3 times 0.75 to the 7, that's h of 7. Those numbers, just write them down. Those are your answers. The last number is a real long decimal, so you could just say 0.4 or 0.4005 if you want to round it off. All right, moving on down. The population of a city increases by 5% every year. So remember, I've hammered this home a lot that the word percent just means divide by 100. So 5% is 5 divided by 100 is 0.05. Okay. However, it says it increases by 0.05. Look what happens if I just go 300,000 times 0.05. Look at that there. Did that increase? No. That went from 300,000 down to 15,000. That is not an increase. That represents how many more people there are, 15,000 more people than there were before. The way that I can get it to increase is by multiplying by 1.05. See? It gives me all 300,000 I started with, and it adds the 5% of increase. 1.05 makes sense because that is 105%. If you have 100%, you stay the same. If you have 105%, you gained 5%. You increased by 5%. So that means that my multiplier should be 1.05, and I should do it for 2 years. So D is the correct answer. This one, part B, would only be doing it for 1 year. This one right here is decreasing, and in fact, it's decreasing by 95%. This one right here increases by 5% and then doubles for the second year. That's not the same. So the only one that works is part D. All right, part A. One second. Okay, so we've got a savings account, 8% interest, compounded quarterly. So remember, you should have this on your note sheet, our compound interest formula. Starting amount, 1 plus interest rate, number of compounds again. The letter N shows up 2 spots in the formula, and then multiply that by time. Okay, so here's this equation. We start with $100. The person invests $100. They earn 8%. So I divide 8 by 100, 0.08. Compounded quarterly, 4 times per year. In 3 years, multiply it by 3. So just type in exactly that, please. I'll show you how it looks on the calculator. That line right down there at the bottom, that's how much money, 126.82. Round it off to the nearest penny. Okay, it doesn't make sense when you have money situations to go 0.824, blah, blah, just to the nearest penny, so 2 decimal places. Okay, number 6, kid is born, grandfather puts $100 in an account, no other deposits or withdrawals for 18 years, and then they get to choose. Okay, so both of them are $100. So option 1, really similar situation to what we just talked about. $100 grows by 10.5%. So I divide that by 100 and I get 0.105 each year. So that's just 1 compound per year. And then 18 years. That's option 1. Option 2 is an account that grows by $20 each year. So all it does is it goes plus 20. And it goes plus 20 over and over again for 18 years in a row. So let's compare this. 101 plus 0.105 over 1 raised to the 1 times 18 versus 100 plus 20 times 18. So we can see that option 1 is better. 603 is bigger than 460. And that's true even though the first year it only earns like $10 and because 10.5%. So it earns $10.50 in its first year versus option 2 earns $20 in its first year. So for the first couple years of the kid's life, it seems like option 2 is better, but then eventually option 1 gets better. I'll just show you real briefly if you wanted to compare the 2 different equations, like year after year, what you can do is type them into your y equals, and you can see in your table that at first, the red one that goes up by $20 is higher. But then by the time you get to, oh wow, not even in the first 10 years, they're still, there we go. So by the time the kid turns 13 is when that exponential growth starts winning. And after it starts winning, it's going to keep winning after that. Okay. So, and it's really hard to predict that. So it could have been the case that the linear won. Like, in fact, if they gave maybe $30 each year, the linear would have been better. Or if the percent had only been 8% instead of 10.5%. So you really do need to run the numbers. You can't just predict. Some people get lazy and they say, oh, exponential is going to win. Well, it's true that exponential will win eventually, but it's not necessarily true that it'll win in the time frame that you're thinking about. No problem. Okay, anyway, almost done. Okay, at the beginning of the year, the number of books was 10,000. Since then, 1% each month. We are expressing the number of books in thousands, so we'll just see the number 10 instead of 10,000. 5 years later. Okay, 1% each month. Okay, so I know that 5 years times 12 months per year means there's going to be 60 total months. So I know that this option right here is good because it's increasing by 1% 60 times. Option E is bad because this one would be decreasing by 99%. If you ran that through your calculator, you'd have a number that's basically equal to 0. This one is increasing for 5 months. This one right here is increasing by 1% over 12 for 60 months. So, like that one, they tried to trick you because they put the over 12 because you're thinking, oh, monthly means I need to divide by 12. But the 1% that they gave you in the problem is the monthly change. It's not the yearly change. So, you don't need to divide it by 12 because it's already the monthly change. And part A is also correct because they just break it down 12 months in a year and then 5 years of that change. And the last one, for which function does f decrease by 15%? Well, if you decrease by 15%, that means you're taking 15 out of 100% and you're left over with 85%. So part B is the one that decreases. Part A would decrease by 85%. Part C would get 15 times bigger, and D would get even 85 times bigger. So the only one that's correct is B. Okay, so please let me know if you have any questions, if you want me to go over anything.